I'm Naida, and I'm going to take you to unremovable limits of a function. First of all, unremovable limits refer to a situation where limits do not exist or where the discontinuity at a point cannot be fixed simply by redefining the function at that point. Types of unremovable limits. First is jump discontinuity. This is when the left and right hand limits exist, but they are not equal. For example, function of x equals.
My hand is tired. Come on. You come and touch it.
For this function, as x tends to negative, our limit is 1, and as x tends to the positive, our limit is 2. This means that the left and the right hand limits are not equal. The second example is infinite discontinuity. Infinite discontinuity. This is when the function approaches infinite near the point. For example, for a function like this one, the limits approach infinity. That's all. Let my friend continue from here.
So my name is Joshua Opolot. I'm going to take you through examples of irremovable or non-irremovable discontinuity, as we have seen through the definition. So we are going to give examples. Number 1. If f of x, if the function f of x is equals to x squared minus 1 over x minus 1. Find the function of f of 1. So when we look through our function here, this one is the function we are given, and we are going to get the function if x is equated or approaches what? 1. So we are going to replace where there is x, we put 1. So we say what about f of 1? This one is the same as 1 squared minus 1 over 1 minus 1. 1 squared is 1. Then 1 minus 1, the answer is 0. Then 1 minus 1 is what? 0. You see here, this one is what? Since the answer is, when you divide the 0 by 0, the answer is 0. This one shows that this function is irremovable. It can be redefined at a certain point. Let us look through our example number 2. Let's say if the function f of x is given to be as x plus 1, for x less than 2, then 3x. For x greater or equals to 2, then they say. So we are going to check through our left hand limits and the right hand limits. our left hand limit, the value of x will be approximated to a negative, and we shall use our first function. So we say left hand limit, the value of x is approximated to a negative 2. Then we use this first equation, x plus 1. This one is the same as 2 plus 1, and the answer is 3. Then the right hand limit, the value of x is approximated to a positive 2. Then we use our second one, second equation, our second function. That means 3x, which is 3 times 2, and the answer is 6. Since the value of the left hand limits and the right hand limits are different, therefore this function here in our example number 2 is irremovable. Since you see the value for the right hand limit is 6, the left hand limit, the value of 3, they are different values, implying that this function is irremovable. Let us look through our example number 3. If the function f of x is equals to 1 over x minus 4, then they are saying check whether this function is irremovable or removable. So we are going to check through. We can put it here for our x being approximating to 4. Or we can start with approximating to, let us use 4. For our left hand limits, f of x, this one is the same as, when we put for the left hand limits, x is approximating to a negative 4. Then we say f of x, that one is the same as, because when we approximate it here to 4, the answer we get will be infinity. When we say 1 over 4 minus 4, this one is 1 over 0. And as we said, we approximate the left hand limits to a negative. Therefore, this one gives us our negative infinity. Then for the case of the right hand limits, the value of x is approximated to a positive 4. Therefore, our function of f of x is equals to 1 over 4 minus 4, which is 1 over 0. Since we approximated the right hand limits to be a positive value, therefore this one is the same as a positive infinity. Therefore, this one is an infinite, irremovable discontinuity. So these are some of the examples we have. And our date today is the 19th of September 2025.